Okay, that was weird. It like said it was recording and then it wasn't. So, all right, I think we're recording now. So we're going to look at, in this lesson, factoring trinomials and moving from the tiles to an abstract area model. So, the tiles are great, and I honestly think that they are one of the slickest ways that we can look at factoring, but they really restrict us in terms of how many tiles we have, how much space we have to work in. Some of you have expressed that you don't like how clunky they are. So we really don't want to be like working with tiles forever, but we'd like to take the concept that drives how the algebra tiles work and make it generic, make it more abstract so we can apply it to more kinds of problems. And that's what we're going to do in this lesson. Now, taking a look at this, we've got the problem 2x squared plus 9x plus 9, and we've got that factored using the tiles. Now, just to recap, so what I can see here is that I have 2x plus 3, and then going down the side, I have x plus 3. And so the factors are 2x plus 3 and x plus 3. Okay, and what I'd like to do is figure out, is there a way I could look at that rectangle without having to draw all those tiles? So here's what we're going to do. We're going to kind of section that off. All right, just like that. Now, if you remember from the last lesson, one of the tips that I said was put all of your big squares in the upper left, build going like to the right and down with your X tiles, and then put your X, your ones, your little constants in the lower right. Not because that's the only way to structure it, but because it's going to allow us to like make what we call a generic rectangle. So this model, instead of looking at it like that, what we're going to do is draw a square basically, but again, we're keeping it generic. And in that upper left, I could have 2x squared, like so. So that would be this blue chunk right here. Okay, and you think, well, how many x squareds do I have? I have 2 of them. Then in this upper right, okay, I have 3 x's, like so. And then in the lower left, I have 6 x's. And in the lower right, there's my 9. Now, if you look at this, okay, you can really see the polynomial there. So you got the 2x squared, 3x plus 6x, there's the 9x, and then there's the 9. And if you look at the factoring on that, you've got x, 2x, 3, and 3. And so there's the factors coming out. So the 2x, 3. So you can see what was multiplied to give you that polynomial. Now, we're going to look at another one just because I want to make sure that we're really getting how we move from that algebra tiles model over to something that's more generic. So like instead of drawing out like 3 x's or 6 x's and drawing out the tiles or moving the tiles around, we could represent that with simply 3x or 6x. Okay, and then we'll think about, well, how can you avoid the tiles altogether? How can we figure that out? So looking at this, now this one might be a little bit better. So we're going to, again, section this off, okay? And we're going to group them by the different kinds of tiles that we have. So in our upper left here, we have 3 of the x squareds. In my upper right, which I've kind of made a mess of that, I'm sorry, that is a negative 1x, because I have just the one red tile. In my lower left, and I hope I said upper right, now I'm second guessing what I said, I have 6 x's, and then right here in my lower right, I have a -2. And looking at the tiles, all right, if we were to try to get the factors, I'd have 3x minus 1. So we could write that as 3x minus 1. And then over here, I have x plus 2. Okay, and so the factors would be 3x minus 1 and x plus 2. Okay, so what I'm hoping you're seeing in the first 5 minutes or so of this lesson is how we can go from that very specific, like here are the areas of the tiles, it's the rearrangement of the tiles to get the area a different way, to this more generic, well, I don't really need to have the tiles, I don't really need to have a rectangle. Like I could do this with a square where each of the 4 quadrants represents the tiles that I would see in that quadrant. Okay, so now here's how we go about doing this. So can we develop a way to factor without having to use the tiles? Yes. If we were going to be wedded to the tiles, this would be kind of a bad way for any of us to teach it to you because you'd be stuck with these tiles like forever. We don't want to do that. So we're going to work an example. I'm going to go through the strategy steps that you see on the left side of the screen, and I'm going to work an example on the right side of the screen so that you can see how the steps relate to the problem. So the problem we're going to factor is 2x squared plus 9x plus 4. We're not going to model it with the tiles this time. We are going to immediately go to the rectangle. Okay, so we've got our tiles and we're just going to jump to the rectangle. Well, what do I know about this rectangle? Well, I know that in the upper left, I'm going to have all of those x squareds. Why? Because that's how I told you, like that's a good way to do it. Is it the only way? No, but it's going to work. Like we can do it that way. And in the lower right section is where I'm going to have all the little tiles, like all the little squares. So that much we know. Now, the tricky part of doing this, even when you have the tiles, is figuring out how to split up the x's. With the tiles, you can do this trial and error. So you can arrange the tiles up, left, right. And if they don't work, you got to move them around and you figure out what works. When you're doing it with a generic rectangle, we don't have that leverage. So we can't just like play around with different things. I mean, I guess you could play around with different things until you found something that works, but it's not very efficient. So we'd like to have like a way that we can get to how do these rectangles split up. So over on the left, you see the method. We're going to take the a value, which in this case is 2, and the c value, which in this case is 4, and we're going to multiply those together. Okay, and those give us an 8. So we're going to take those two numbers and multiply them together. If you happen to have a 1 out in front, that is even nicer, okay? Like a 1 out in front would be really good. But we don't in this one, we have a 2. Now, we're going to factor that number into the factor pairs. So I'm going to take the 8, and I'm going to break that up into factor pairs. So for factor pairs, I have 1 times 8 and 2 times 4. Okay, that's what I've got for my factor pairs. Now what I want to look for is I want to look for the pair of numbers that's going to add up to give me that 9. Because remember, what we're trying to do is we're trying to split up like the x's. And the reason I multiply the a and the c together is because that's how many, like essentially like how many, oh gosh. You know, I'm gonna have to back up. Like it tells you how many like layers of stuff you have on each side. So you have like 2 of the x like layers on one side and like 4 on the other. You know what? If we could look at the tiles, I don't have the tiles for this one. You'd see it better. But anyway, you look for the ones that add up to the 9. Well, 2 and 4 don't add up to 9, but 1 and 8 do. And so that basically tells you how you're breaking them up. Now, it actually doesn't matter which way you put them. And that has to do with like the rectangle being, okay. Like you could have the rectangle like this, or you could have the rectangle like this, but it's the same rectangle. Like if I were to find the area of this index card, okay, I can measure the base times the height and I get an area, or I could hold it this way and measure the base times the height and I would get the same area either way. It doesn't matter. So you can stretch it out like the long way and put the 8x this way, or you can put the 8x over here. Like that part won't matter. Now we've got that set up. So now we just need to figure out, okay, what are the things on the outs, hang on, I can do this. On the outside here, that would multiply to give me like what's on the inside. Now, the easiest way to do that is you can pick any row, any column. Okay, any row, any column. So I could do this row, or I could do this row, or I could do this column or this column. You got 4 choices to pick from. Pick whatever you think is the easiest. I typically will do either the first row or the first column, whichever direction has the smallest numbers and doesn't make me tangle with negatives. So for this one, it's going to be this direction right here. And I'm going to find the greatest common factor of 2x squared and 1x. So this is why we have to cover the GCF factoring first. So the greatest common factor between 2x squared and 1x. Well, we got a 2, we got a 1, that's not in common. I've got 2 x's here and 1x here, which means what I have in common is an x. And that is all the actual factoring you need to do. The rest of it is going to be multiplication. So something here times the x gives me 2x squared. Well, that's going to be 2x because 2x times x gives me 2x squared. X times something gives me 1x. Well, that would be a 1. 1. 2x times something gives me 8x. Okay, maybe you're like, I don't like 8x, that's too big. All right, well, let's look at this. 1 times something would give me 4. That would be 4. And then you can use whatever you didn't as your check. So 2x times 4 is 8x. So now you can double check each box. 2x times x is 2x squared. 1 times x is 1x. 2x times 4 is 8x. And 1 times 4 is 4. And I know that all of those work. So the sides of that rectangle are 2x plus 1 and x plus 4. And we've got it factored and we didn't have to use the tiles. Now that I worked through, that took me a little less than 7 minutes. That was with all the explanation. It should go faster the more you do it. So the first example is always the longest, most detailed. Let's take a look at another example. Now on this one, I am going to have the tiles like appear on the right-hand side, so we'll be able to check it. So to do this with a generic rectangle, we're going to set up the rectangle. Okay, and we know that all of the x squareds end up in the upper left. All of the little squares are going to end up in the lower right. We know that that's what happens. Now the trick is I've got to figure out how those x's are split up. And if you remember from doing this with the tiles, whenever you have the negative out here, that's when you need to add those 0 pairs, because you can't have a positive times a positive give you a negative. So we got to kind of think about how's that going to look. Now in this one, my a value is 1 and my c value is -4. So we're going to multiply those together. So 1 times -4 is -4. Now I need to factor the -4 in such a way that I get numbers that add up to +3. Now, here's what I do, okay? I actually ignore the negative for a hot second. All right, like I don't ignore it forever. I just kind of ignore it for a second. And I say, what numbers multiply to give me 4? So what are my factor pairs? I could have 1 times 4, or I have 2 times 2. Obviously, the bigger the number you have out there, like the worse the problem is, because you could have lots of pairs. Now, I am aware that I've ignored the fact that it is negative. Now, the fact that they have to multiply to be negative means that essentially I've got to subtract the numbers. And so what I do is this. I actually maybe don't even think about the negative yet. I say, what could I get from a 1 and a 4? Well, if they're both positive, I could get a +5. Like 1 plus 4 would give me 5. And if they were both negative, I would get a -5. -1 times plus -4 is -5. If one of them is negative, okay, I could get like a 3. So if the 1 was negative, I would have -1 plus 4. That would give me 3. And if the 4 was negative, I could have 1 plus -4, which would be -3. Okay. And there's actually 4 different ways to do that. So I kind of run through that. Okay, if I add them, I get this. If I subtract them, I get this. So basically, like I think this way. If I add them together, I get a 5. If I subtract them, I get a 3. And I can get either a +5 or a -3, like either way. And you can do the same thing with the 2's. So if they're both positive, you end up with like a +4. If they're both negative, you get a -4. And if one of them is negative, they would add up to a 0. So we're looking for a 3, which means that we're definitely like interested in that pair. And the way to get a 3 is if the 1 is negative and the 4 is positive. So just kind of stop for a second before we jump and write them into our area model. If I multiply these, -1 times +4 is -4. And if I add them, -1 plus 4, I get 3. So I'm confident I have that correct. And I'm going to go ahead and put the -1x in there and the 4x in there. It does not matter which way you put that. And now we want to look for a greatest common factor. Okay, greatest common factor. And I'm going to go this direction. So what is the greatest common factor between x squared and 4x? Well, they don't have any number part in common, but this one has 2 x's, this one has 1 x, therefore they have an x in common. And from here on out, we're just going to multiply. So x times what gives me x squared? Well, that's got to be another x. X times what gives me -1x? That's got to be a -1. And x times what would give me 4x? Well, that would be a 4. And then use the last box as your check. 4 times -1 is -4. And if you add all those up, you get your original problem. And so we have x minus 1 times x plus 4. Ta-da. All right, now let's see how I did this. Okay, so I arranged it like just a little, I arranged it the other way. But hopefully you can see what's on there. Wait a minute, this is the one with the animation. It's super weird. So it says both arrangements are correct, and then I don't even have that, like the arrangements is on 2 different lines. There's the one. Okay, so this is the one that we ended up doing in this class, and we might end up doing like a different one in class. So we ended up looking at this one where we've got the x squared in the upper left. We have the -1x in the upper right. The 4x is in the lower left, and the -4, of course, is in the lower right. Now, we could have done it this way. So remember I said it doesn't matter where you put them. All right. So if I had done it the other way, then we would have had the 4x in the upper left and the -1x in the lower right. But it's the same rectangle. Okay, same rectangle. And both of them would give you an x plus 4 and give you an x minus 1. So you can check that with the algebra tiles and got to confirm that you have it set up the right way. All right, now what if there's a GCF? So if there is a GCF, so if there is a greatest common factor in your polynomial, you want to factor it out first in order to make the numbers smaller. Okay, now looking at this, okay, I am not liking that. That 48 is huge. And remember, I'd have to do 2 times 48, so I would have like a 96. I don't want to factor in 96. Okay, and neither do you. Like none of us want to factor in 96. Like no. But what I do notice is that I have a 2, a 20, and a 48, and they are all even, which means they all have a factor of 2. So we can factor this into 2 times x squared. This is 2 times 10, and this is 2 times 24. So we have a common factor of 2. And we're left with x squared plus 10x plus 24. Now, I'm not super thrilled with the 24. Okay, that's still bigger than I would like to have a factoring problem, but it's way better than 48, and it's eons better than a 96. Okay, so not thrilled, but also like we're not going to complain either because it's so much better than it was. All right, now over here, I'm going to go ahead and set up our model. Now, all I have to look at is that part. So the x squared goes in the upper left, the 24 is going to go in the lower right, and we're going to multiply 1 times 24 to get 24. Okay, and now we've got to look for those factor pairs of 24, and we're looking for something that's going to add up to the 10. In other words, we're looking for the way to get it broken up, but we have to like keep the 10 x's. So this is where your times tables come in. Like, you just got to know them. 1 times 24, that does not add up to 10. 2 times 12 doesn't add up to 10. Now they could subtract to give you a 10. So, but I don't want to subtract them in this case. We have 3 times 8 gives me 24. And my last pair is 4 times 6. Ding, ding, ding. We have a winner. So the 4x and the 6x. So we're going to have 4x and 6x. So that's how you break it up. And then we're going to do GCF. It doesn't matter like where we do it, but I'm going to go x squared plus 4x. Well, I've got 2 x's and 1 x, so the greatest common factor is x. Then x times x would give me that x squared. X times 4 would give me 4x. And x times 6 would give me that 6x. And then you have the 6 times the 4 gives you the 24. So this factors into x plus 4 and x plus 6. And then don't forget you've got that 2. Don't forget. It's a 2. We got the 2 at the beginning. If you don't get it out at the beginning, what's going to happen is one of your parentheses is going to have the common factor in it, and you would have to get it out at the end, and you just make the problem so much harder by not getting that common factor at the beginning. So there you go. All right. Now, where do we go from here? That is what the next slide says. Now, the goal is to move away from needing the tiles and working completely on paper. So we want to move away from needing the tiles and move towards working completely on the paper without the tiles. But you may continue to use the tiles in class to check your work or to help you if you get stuck. So what I want you to be doing is setting up this, okay? And you're going to put your x squares in there, and you're going to put your numbers down there, and you're going to put your x's in here, okay? And try to get it factored where it's coming out correctly. And then you can go check with the area, the tiles. Or if you're just legitimately getting super, super stuck, you can use the tiles to help you figure it out. But we do want to move away from that because we don't want to be wedded to the tiles. I will allow you to use the tiles on the test, but you would use the tiles to supplement what you're showing on the paper, not instead of what you're showing on the paper. Okay, so practice set, finish for homework if needed. Factor each expression completely. That word completely means that you've got to get a grade, like the GCF if there is a GCF. Okay, it means you can't leave it inside. Use the tiles to check your work if needed. So the first 8 are basically just factoring problems. So you're going to try to do those. You try to get those factored out. They do mostly move from easier to harder, not exclusively moving from easier to harder, but generally speaking, they get more challenging as you go through. Some of them will have a common factor. I think you can kind of see like whether they have a common factor or not. Now for number 9, it says, look at your work for the problems above. You should have an attempt for every single problem. So there's nothing that's blank, nothing that says IDK. Okay. Nothing that says, oh, I struggled with it. Okay. If you're going to struggle, then I need to see your attempt. Okay. I need to see your attempt that showed that you struggled with it. Now what I want you to do is list the numbers in order from your most confident to your least confident. So going through them, is it 1, 2, 3, 4, 5, 6, 7, 8, like most confident to least confident? Is there like, maybe it goes like 1, 3, 4, 2, something, maybe you have like 1, 4, 7, 8 are your most confident. Okay. 1, 4, 7, 8, and like you can kind of maybe think about why I said that, or whatever. Okay. But just kind of go through, reflect, and then look at the bottom 3 problems. Maybe the bottom 4. I don't know. like the bottom chunk of problems. And I want you to look, do they all have something in common? Is there something about those problems that's causing you to feel less confident that you've done the problem correctly? If so, write a question you can ask in class that addresses that specific thing. Okay. Like, Miss Taylor, I don't know what to do when I can factor like the leading coefficient, or I don't know what to do, or what do we do, or I am not confident. Like, try to phrase it as a question, like, what do we do when the numbers get really big? What do we do when we have a minus sign at the end? What do we do? Like, so try to phrase it as a question and be prepared to share your question. Okay, so that is those are legitimate questions. If you leave 9 and 10 blank, you will lose points on your homework if you leave them blank. Okay, so we need to see an attempt for everything and a list, and then a reflection on what you think is the issue with that causes you to not be as confident. Okay, all right, you guys know, as always, where to find me, and I will see you next class.